Okay, let's look at the homework 2.6, problem number 6, right? So we have the curve with the equation y squared equals x cubed plus 3x squared. It's called, I can't even pronounce it, Schoen-Hansen cubic, right? Find an equation of the tangent line to this curve at the point 1, 2, right? So let's do that. All right, so we need to find the, so the point is given, so this guy is already x1 comma y1, so we just have to find the slope m, right? So let's take the derivative. So take the derivative of the left-hand side, which is y squared, with respect to x. Then we take the derivative of the right-hand side with respect to x. So it's x cubed plus 3x squared. All right, so this is going to give us, all right, so it's 2y, but we have to multiply by dy over dx. So this is basically the chain rule. And derivative of that, it's just a regular derivative. So it's a 3x squared and a plus 6x. All right. Then we just need to divide through by 2y. So divide through by 2y so that we can isolate dy over dx. All right. So this is going to be 3x squared plus 6x over 2y. All right, so if you want, we can factor out the top. So you have 3x in both terms. So pull out 3x. So you have x plus 2. And then you have a 2y. Right? So if you want to find the slope, so slope m is going to be take dy over dx, evaluated at x equals 1 and y equals 2. So you're going to plug in 1 here, so it's going to be 3 times 1, 3 times 3, so it's going to be 9 over, and y is 2, so 2 times 2 is 4, right? So the equation is going to be, so therefore, it's going to be a y minus 2 is equal to 9 quarters times quantity x minus 1, right? So we have that. So we have, we can probably, we should add 2 to both sides. So we have a 9 over 4 times x minus 1 plus 2. All right, then we want to find the, let's see, the point at which this curve has a horizontal tangent line. So we just need to set the derivative equal to 0, right? So we have, so derivative came out to be 3x times quantity x plus 2 all over 2y is equal to 0. So this was the slope. All right, then we can see that we can set the numerator equal to 0. So it's going to be 3x and x plus 2 equals 0. So therefore, we know that x is either 0 or negative 2, right? Then we just need to find the corresponding y value. So x equals 0. So when x equals 0, so put 0 here, y is going to be 0. So y is equal to 0 as well. And then put, let's see, x equals negative 2. So you can see that, so negative, so it's negative 8 plus, right, so it's a negative 8 plus 2 squared is 4 times 3 is 12. So negative 8 plus 4, so sorry, plus 12. So that's going to be 4. And so y squared is equal to 4, so it's going to be either plus or minus 2. All right, so let's see. So I'll point out which the graph of horizontal tangent line. Then looks like looks like we have 3 points, but the one of the point wouldn't be the right one, because here when x equals 0, y equals 0, which means that here the derivative, it has a 0 on the bottom, so that would be a problem. So we ignore that. And then, so you have y is either positive 2 or negative 2. So larger y, so it's going to be a positive 2. And this one, smaller y value, negative 2. Corresponding x value is negative 2 and a negative 2. Right? So let's type these guys in. All right, so the slope was 9/4. Right? Then you have x minus 1 plus 2. Right? Then x was negative 2, comma, negative 2, and also negative 2, comma, positive 2. Right? Then I'm going to go here and look at the points at which curve has horizontal line, and let's look at the graph of these things. All right, so let's see. So you can see that the negative 2 comma positive 2 and the negative 2 comma negative 2, so horizontal tangent line there. And the tangent line at 1 comma 2 is has a 9/4. So this is promising. Not this one. And is there anything else? Not this one and not that one. So it looks like this is the graph that we're looking for. All right, so let's submit for testing. All right, it came back and looks like we got the part A correctly and part B correctly, and we got the graph correctly as well. All right, that's it. I hope that this was clear.